Hello, Descent team. Right now, I'm going to show you how to code and build your circuit for the descending portion. It's going to take place partly, of course, in the Arduino IDE like this, but also I'm going to show you how to do it in Tinkercad. This is just a way to visualize what we're working with here. You're going to build this in real life. I have it here virtually. We have Arduino, and I have a couple things here that will help. We have a LED and a button and a buzzer, just like we had before in the electronic music. And then this is our altimeter analog. This is not actually the altimeter; it's just a different sensor. This website doesn't have altimeters in it, but I'm going to show you how we're going to wire this up. So we're going to start by taking um, a jumper and go from the ground in the Arduino right into here. These sides here are called a bus. It allows you to add power to here, just right here, and it will, um, and so you can now tie into power, the 5-volt power from right here. I'm going to then get a red wire and go from the 5 volts here and tie it in right there. You could also, if you wanted to, tie it into both sides. If you wanted to, it's up to you. Each of these objects are going to go to ground as well. I can even put them in here if I want to, which I should. Why not? It's all the same. It's all fun. Um, but sometimes it's easier to visualize it when they're not on there. So let's do the LED first. The LED, I'll get orange wire here, is going to go from pin number 2. That's a lie. Pin number 4. I'm going to go from here mm, over here to the cathode. So this is going to end up being positive voltage there. And then we need to tie in the other side to ground. This is going to look ugly for a while, and that's okay. Um, it's not. It's going to be a rat's nest of wires. Your button is going to do something very similar. It's going to go from the ground, just like here, and then it's going to go into another into another pin here, and go into pin 2. That's the one that goes into 2, right there. And notice it's all black because it's all coming from ground. You could change this color if you wanted to. It doesn't matter. All the colors do the same thing. This speaker is going to be hooked up to pin 5. So one side needs to be ground, right? We did this before. And then the other side we'll do green. Why not? We'll go from positive here to pin 5. Cool. On your altimeter, you'll see that you will have codes. You have to plug the ground into one side. They're all labeled on the altimeter. This one's not labeled. It'll also need 5 volts power, just like this. And then it has 2 data lines. One is called SCL, and the other one is called SDA. We'll go turquoise here. The SCL will go from there to pin A5, which is right here, the A side. SCL goes from the SCL pin on the altimeter to A5. And then the other one, we'll do purple. It's called SDA. We'll go to pin A4. So this is now our completed circuit. We have an LED, we have a switch, we have a buzzer, and we have our altimeter right here. It's 5 volts ground, SCL, and SDA. That stands for clock and data, by the way. Cool. Once your circuit is built, it's also in your packet if you want to see the actual circuit diagram. You're going to create your script. The script needs some extra data. It needs a library that's been created for this project specifically. So what you're going to download the library. It's called eyw.doth.zip. Keep it as a zip. You don't need to extract it. Then you're going to go from here to Tools. Go to Include Library or Sketch rather. Include Library. Add .zip library. You're going to go into your downloads, which is probably where it is. And it looks right here. You're going to then download, click open, and it will insert the download your EYW library and put it into your script. To make sure that it's being included here, you type in the word hashtag include, then the left caret EYW dot H right caret, just like that. At the beginning of the script, we need to start our variables, our pin variables. If you remember from the script, or rather the circuit that we've already done, we need to figure out what those are. The need to have switch pin, button rather. It's called a button. Button pin is going to be 2. The LED will be pin 4. And we need to use the speaker pin E5. I think that is all as far as pins go. Cool. Now, we have to turn the altimeter on. We have to initialize it. We're going to do that outside of the setup and the loop as well. You're going to type in EYW and it will turn orange, then 2 colons, and then altimeter. Now also turns orange. We're going to name the altimeter my altimeter. Why not? A little boring, but it works. We also have to set up the initial height. So whenever you turn this on, it's going to be on the ground, and this sets the height as 0. So we need to create a float variable this time. Call it current. I'm going to set it equal to 0, like that. So this is all sort of a bunch of material that we have to get out of the way right off the gate, so we can start coding up the actual algorithms that make this thing work. Inside here, inside the void setup, we need to turn something on called the serial monitor. This has nothing to do with breakfast. This is a way for you to be able to write statements in your Arduino that will then display on your computer, so you know what's happening. It's the only way for you to get the data from your altimeter. You have to be able to see it. So we're going to type in serial.begin, and the argument is 9600, which is the speed in which this data can get to the computer. We then have to turn on our altimeter, which is called my altimeter. And my altimeter.begin is what it is. Close parentheses. That's fine. And then we need to type in current height underscore equals my altimeter dot get height. What this is now going to do, it's going to rewrite the current height variable from right here with what the data it's getting from the altimeter. Then we need to print some of this data to the serial monitor. When we do this by typing in serial.print, open up parentheses, and then open up quotations. This is going to be a statement. This is now going to be text. And we type in uh, calibration height reading. And like just do an equals in a space like that. Like that. It's whatever you want. You're just telling it that this is text for you to know what the next variables are. Then we're going to type in serial.println, which really just hits enter after it prints the next line. We're going to type in current height. This is not in quotations because it's not a string. This is actually going to be the value that's coming out of our altimeter. Cool. Once it does that, we're going to want to calibrate our reading so that that is now the zero height. The values that are coming out of the altimeter are now going to be set to the height of 0. So my altimeter calibrate, and then 1,000, which I think takes 1,000 readings if I remember correctly. 1,000 measurements, which is really fast. You should only take a couple seconds. And then once that's done, we want to signal that it has done something. So we type in my altimeter alarm. And we need to put in a couple variables here. The first one is going to be the speaker pin, which is, I think it's speaker pin, right? No, it's not. Never mind, that's a lie. We want to play 3 notes um, at the 880 hertz for a second each. That is. And then you could do a comment here. How many notes, frequency, and then and at this point, you can check your code to see if it is all good. And once it is, which it's not, serial capital S. You can check your packet to figure out how you're going to create this code to work. What's it going to do? When's it going to start taking pictures, etc. You might want to talk to your payload team as well, because they're going to know how to make the servo actuate. Cool. I hope that was helpful.